We're going to start with lesson 2, the multiplication of polynomials. So in this video, we'll start with an opening exercise that's found at the beginning of this particular lesson. And it says, show that 28 times 27 is equal to 20 plus 8 times 20 plus 7 using an area model. What do the numbers you placed inside the 4 rectangle regions represent that you drew? So if we're going to use an area model, we're going to start by putting in a square or a rectangle. So we'll draw a square. And inside that square, we will put a couple of lines. One that goes down this way, and then we'll put one that goes across this way. This is your basic area model. Granted, 20 is bigger than 8 and 20 is bigger than 7. You don't have to necessarily draw them to match that idea. This is just a diagram. So if I was to represent this using an area model, I would put 20 on top of here, and I would put 8 on top of this square. Then I come over here and I would put another 20, and then come over here and I would write a 7. And so using this area model to multiply polynomials, we're going to take basically what's on the top of this square, on the left of this square, and multiply them together. So 20 times 20 would be 400. And then if we did 20 times 8, we'd get 160. If we do 20 times 7, we're going to get 140. And then if we do 8 times 7, we're going to get 56. So kind of the idea behind this model is we would then add up all these numbers. And just to kind of get ahead on this idea, we would kind of take numbers out by diagonal. So if I took this number out right here, that would be 400. If I took all the numbers out in this diagonal, 160 and then 140, that would be 300. So we'll put plus 300. And if we took all the numbers out in this diagonal, that would be 56. So the idea would be that if I add these three numbers together, I'd get 756 using the area model, which would be the same thing if we took and multiplied either in this fashion here. If we took 28 and we multiplied that by 27, and I won't do all the work, if I multiply those together, I would get 756 to match. So that's kind of the idea about the area model. Now, obviously, you might be thinking, why would I even want to do the area model for that if I could pick up a calculator? Well, this is going to expand us into what we're looking at in this particular lesson, is the multiplication of polynomials, such things where we have variables and so forth. So in example number 1, they already have the tabular method set up. They haven't finished it. They haven't combined the like terms yet, which is what we're going to do in this particular example. But this one is set up as an example for us to look at and observe and see how is this similar or related to what we just did. So here we have x plus 8 times x plus 7. So notice in the top we put an x here in this location. We put an 8 here in this box. On the side, which is written on the right, it doesn't matter whether you write on the right or on the left. We have an x and then we have a plus 7. So if we combine everything together, same idea. If we multiply the x times the x, we get x squared. If we do 8 times x, we get 8x. If we do x times 7, we get 7x. And if we do 8 times 7, you get 56. And so in this particular case, notice the arrows that are here. We pull things out diagonally in fashion. X squared is here. 7x plus 8x is 15x. And then you have 56. And so my final answer would be x squared plus 15x plus 56. Now, this is essentially our problem that we just did broken down as a polynomial. Remember last time we had 20 plus 8 and then we had 20 plus 7. What we basically did is we took the 20s out, we put an x in its place. And so as opposed to getting 756 last time, which is what we would have gotten with the 20s, we get a placeholder piece, a polynomial of x squared plus 15x plus 56 in that particular piece. So this is the model we're going to illustrate and focus on when it comes to solving in polynomials. So next up comes a couple of exercises. So again, here in the video, I would recommend that you stop by pausing the video and try exercise 1 and see if you could set up the table and put the place values where they belong, and then I would unpause the video and then I would see how you set it up, and then I would pause it again, try and solve it, and then come back to the video and see if you solved it correctly. Either way, if that's the way you choose it, go ahead and pause the video and try and set up the table. I'm going to continue on. So to solve this one, I would start by putting in a table or a box. So I'll draw a little bit of a larger box this time, because if you notice, we've got 1, 2, 3 terms and 1, 2, 3 terms. So I want to save myself enough space to be able to draw this. So I'm going to put a line here and put a line here. We'll go across, right? And then we put another one here. You know, if you're using a ruler, you can measure these out exactly. Like I noticed it's not exactly even. They don't have to be even. This is just for those who like that kind of thing. And so you see I kind of evened it out a little bit. So to solve this one, I'm going to start by writing x squared on top of this one, plus 3x here, and then plus 1 on top of this one. Now again, you can either write on the left-hand column or the right-hand column. I like to write on the left-hand column. So I'm going to write x squared, and I'm going to put minus 5x. This is going to serve as a negative 5x, and then we're going to put a plus 2, and that again would serve as a positive 2. So what we do is we're going to multiply everything that relates from column to row. So everything in this first row is going to get multiplied to each of these columns. So x squared times x squared is x to the 4th. We add those exponents, by the way. And then x squared plus 3x is 3x squared. And then x squared times 1 is x squared. And actually, let's go back. I didn't add 2 plus 1 is 3. And then x squared times 1 is x squared. So now we're going to take the second row and multiply it to every single column. So negative 5x times x squared is negative 5x to the 3rd power. Negative 5x times 3x is negative 15x squared. And then we get negative 5x. To continue on, we'll go to the 3rd row and multiply it to every single column. So 2 times x squared is 2x squared. 2 times 3x is 6x. And then 2 times 1 is 2. So this fills in our grid for the area model. Again, we're going to take and we're going to pull these out in diagonal fashion. So we'll pull out this diagonal, this diagonal, this diagonal, this diagonal, and then this one. So when we start to write our final answer, this is the only x to the 4th that I have, so I write x to the 4th as my first term. And then this has an x to the 3rd, and this has an x to the 3rd. Those are like terms. So negative 5x to the 3rd plus 3x to the 3rd is going to be negative 2x to the 3rd. That'll create the second term in our polynomial. So if we go across this diagonal, all the x squareds, 2x squared plus negative 15x squared plus x squared, we're going to get negative 12x squared. 6x plus negative 5x will be 1x, so I'll just put plus x, and then I have a plus 2 on the end of this problem. So that is the result of our polynomial multiplication using the tabular method. There are no like terms to combine after we get to this step. All our like terms were combined in that diagonal fashion. So again, look back, see how you did. If you made any mistakes, obviously note the mistakes you made, so that way when we move on to exercise number 2, you have an opportunity to look at these mistakes from a different perspective. So here's exercise 2. Again, I'd recommend you pause the video or go ahead and solve it with me if you're not sure, if you struggle with exercise 1. But if you think you know it, again, try to set the table up. Notice this time it is a 3-term by 2-term, but in this 2-term it's missing a place value. So you might want to consider, how would I deal with this concerning placeholder value, the linear term, and setting it up. So again, pause it, see if you could set up an idea, and then unpause it and see if you came up with the same idea that I did. So I am going to again draw a square. Again, you might be thinking at this point, well, wait, why are we drawing a square? Because obviously this will look like it would be a 3 by a 2. And if you did that, that is fine. You do not have to erase your problem and start over. But consider what I'm going to show. I've got 3 terms here. So I'm going to write x squared plus 3x plus 1 here on top. When I look at this one, I'm missing the linear term. Like, I see x squared and I see x squared. So I would put an x squared here. I'm missing the linear term, so I'm going to put a placeholder value of 0x. 0 times anything is 0, so it's not like it's really there, but it will serve as a placeholder to allow all of our like terms to diagonally show up. Now again, if you want to do a 2 by 3 model, that's fine. Nothing wrong with that. So if we fill it in, x squared times x squared, we're going to get x to the 4th. And then x squared times 3x is 3x to the 3rd. And x squared times 1 is x squared. Now, because this is a placeholder value, all of these are going to have zeros. 0 times this. So you'll have 0 x to the 3rd, 0x squared, and this will be 0x. So again, these are placeholders. The reason why I like putting the placeholders, again, you could see that the like terms diagonally match. If you didn't do that, then you're going to have to kind of look a little more carefully. So here you get negative 2x squared. Here you get negative 6x. And here you get negative 2. So we're going to prepare to combine like terms. So all of our like terms are in diagonal. Again, mine are in diagonals because I use that placeholder value here. So when I write the final answer, I get x to the 4th. 0x to the 3rd plus 3x to the 3rd is 3x to the 3rd. Negative 2x squared plus 0x squared plus x squared is going to give us negative x squared. Negative 6x plus 0x is negative 6x. And then our last term, our constant, will be negative 2. So that's exercise number 2. Next up in this lesson is example number 2. And again, this is already a preset piece for us, so we're just going to kind of model it and look at it and see what's happening. And in this case, we have a situation where we have x minus 1 is multiplied to x to the fourth plus x to the third plus x squared plus x plus 1, and it wants to generalize the pattern. Again, you could use placeholder values if you wanted to have a square piece, but in this case, they did not. They put the x minus 1 on top, x to the fourth, x to the third squared x, and then 1. Typically when I write it, I like to put the plus signs. It's not necessary unless there's a negative sign there, but in any case, these are all positive. And notice what happens in this case, and this is a unique case, right? You get your x to the fifth, and these end up being opposites every time on the way down the line. So the only thing that ends up being your answer is x to the fifth minus 1. Everything else tended to go away or cancel out or not be a part of the problem anymore. The last two examples tend to take us a little more general. Let's see if we can make this show up again. There we go. And what if we just took and looked at some of the numbers? Now they just say multiply this using the distributive property. So this is a skill that, theoretically we already bring into this idea. We're going to make that look a little bit nicer when we underline that. So the distributive property is what we're going to look at, and then combine like terms. How is this calculation similar to example number 2? And you're just going to see that the pattern is going to play out in the same general idea. But if we did, right, we would write x minus y, and then x to the third plus x squared y plus x times y squared plus y squared. So we're going to do this with distributive property. It also gives you a chance to remember distributive property if you forgot. What we're going to do first is take this x value and we're going to multiply to every single one that we have over here. So x times x to the third is x to the fourth. And if we do this again, we'll go to here. And so this will become plus x to the third with a y. We'll distribute again. So that'll become plus x squared with a y squared. And then if we multiply this one to here, we're going to get plus x y squared. Now then we're going to switch over to this one. Now we're going to do this one times this one, so that'll become negative x to the third with a y. I always write my variables in alphabetical order, so I'm not going to write negative y x to the third. I'm going to write negative x to the third y. You'll start to understand why that notation design is important in a minute. So we do this one, so again this will be negative x squared y squared. And then let's see, multiply all the way to over here now. Let's draw that arrow again so it looks nicer. We don't want any confusion. This will go all the way to this term. So we'll have x, so we'll have negative x y to the third and if we go one more time, right, we come all the way out to here, and that'll become negative y to the third. We'll double check, make sure everything looks good. First term looks good, second term looks good, third term, and then, yep, I think I'm pretty happy with that. Negative xy to the third. Okay. that might be one challenge that we're just noticing. I don't know what it is in your book or not, but I just noticed, and some of you might have been screaming at me on the screen, that that's a 3 in my book. And so if that's the case, let's go to make 2 changes. I believe that's going to really only affect this term back here and change this to a 4. Here. And so the goal was to see that this and this one cancel out, this one and this one cancel out, and this should have become a 3 with that change. And then this one cancels out, so our final answer ends up being x to the 4th minus y to the 4th. Okay, one more example. Example number 4, and then that's it. And that'll conclude what we're going to generally talk about. As I say, what if we were to multiply these two together using the distributive property and combine like terms, generalize the pattern, and so forth. So in this case, let's say we do the distributive property. We have x squared minus y squared, then x squared plus y squared. And so if we did the distributive property, make sure it's all written correctly, it is. This one times this one would be x to the 4th, because we add the exponents. And then this one is going to be plus x squared y squared. And we'll take this one, and again, keeping it in alphabetical order, that would become negative x squared y squared. And then if we multiply this one times this one, that would become negative y to the 4th. So what is our final answer? Well, this one and this one would cancel out, and we get x to the 4th minus y to the 4th. So in closing, the video is here to aid you. The benefit to the video is you can watch it again if you need to. You can fast forward or rewind to something you need to see again. At the end of your section, there's some relevant vocabulary. I'd recommend you take a minute and look at those. Other than that, you would go to Google Classroom, find out what the assignment is going to be, and then solve those problem set problems from there. And again, you can find all of that in Google Classroom. So if you have any questions, let me know. Thank you.